Today we're going to look at this idea of Pythagorean Theorem. Now we're going to see when I'm working with Pythagorean Theorem, we are actually working with a right triangle. Now if you remember from last year, the side that's opposite the right triangle is the hypotenuse. Okay, so the hypotenuse is always the longest side, and it's the side that's opposite the right triangle. Now, the other two sides are considered legs. Okay, so Pythagoras came up with his theorem, and it can be used to find the lengths of the sides of a right triangle. So we're going to see then in any right triangle, the square of the length of the hypotenuse equals the sum of the squares of the lengths of the legs. Now, if I'm going to use a formula for that, we've got the sum of the legs squared. Remember, the legs are A and B, equals the hypotenuse squared. Okay, so that's our formula that we're going to use. And again, we're only going to use Pythagorean Theorem when I need to find the length of a side. So if you look here, let's go ahead and get some of my words out of the way. In this problem that I have here, we're actually solving for the hypotenuse. Like we know that each of our legs are 3, and we're solving for C, the hypotenuse. So let's plug in what we know. Well, the first side is 3, so 3 squared. The second side is 3 as well. So now we've got 9 plus 9 equals C squared. We've got 18 equals C squared. Now remember, that's C squared, but I need C. I need just the hypotenuse by itself. So we're going to have to take the square root of that. So C equals the square root of 18. And now, here's what I need you to remember to do. If I can simplify that radical, if it's not a perfect square and 18 is not a perfect square, we need to simplify that radical. So C is going to be 3 root 2. Remember, we've been doing this for about a week now. This is 9 times 2. 9's my perfect square. So we get the square root of 3, or 3 root 2. Now, let's go ahead and look at a couple others. If you look at my next triangle, if you notice, I gave us one of the legs. I gave us this leg, and I gave us the hypotenuse, and now we're looking for B. So I left some blanks for you. If you notice, I've left some blanks. So let's see. We've got A squared. We'll make that 8 squared. Okay. B squared is the other leg we're trying to find. Hypotenuse is 10. So we've got 64 plus B squared equals 100. Now, who do I have to move to get B squared alone? That's right, we've got to subtract 64. So we're going to get 100 minus 64, which is 36. And so B squared equals 36. So B is the square root of 36, which is 6. And again, we got to put units because we're measuring 6 centimeters. All right, great job. Now, we're going to see that there is this idea called the converse of Pythagorean Theorem. So what they're going to do is they're going to give us 3 measures of the legs of the 3 measures of the sides of a triangle. If you notice here, they give me 8, 15, and 17. And they're going to say, state whether or not the 3 given numbers could represent the lengths of a right triangle. Well, first thing we've got to do is we've got to realize that we're going to assume that the biggest number is the hypotenuse. We've already saw that on our last slide, that the hypotenuse is the longest side of the right triangle. So we're just going to plug them in. So 8 squared plus 15 squared equals 17 squared. 64 plus 225, and we're going to see that 289 does equal 289. So since we got a true statement, okay, because 289 does equal 289, therefore, we're going to say that these 3 sides could form a right triangle. Now, let's let everybody go ahead and try number 2. Again, we're going to have 16 squared plus 24 squared equals 30 squared. Okay, go ahead. You can use your chart on page 681, and let's see if we get a true statement or a false statement. that's right. We got a false statement. So therefore, we would say that a triangle that has the sides that measure 16, 24, and 30 could not form a right triangle. Now, big deal with Pythagorean theorem is this idea of story problems. It says, find the length of each diagonal of a rectangle whose dimensions are 33 by 56. So when I look at this, well, what's a diagonal? Well, if you remember from math past, diagonal goes from opposite corners. So if you notice, it actually takes and it cuts my rectangle into two right angles. Now, if you notice that that diagonal is actually the hypotenuse. It's the hypotenuse of my right angle, or my right triangle. So we're actually solving for C. And it tells me my dimensions are 33 by 56. 30. Okay, so we can just use Pythagorean theorem to solve. Okay, so if we're using Pythagorean theorem to solve, let's go ahead and plug those numbers in where they belong. Okay, you may need to get page 681 out so you can have some help with finding those perfect squares there. Page 681 in the back of your book, our new best friend. All right, so here we go. We got 33 squared plus 56 squared equals C squared. Well, if you look in your chart, 33 squared is 1089. 56 squared, again I'm looking at the chart on page 681, is 3136 equals C squared. What happens when I add those together? Well, 15, 12, 2, 4225 equals C squared. So that means C equals the square root of 4225. And if you look, that's on your list. Okay, the square root of 4,225 is 65. So C equals 65 centimeters. Okay, so we've seen then that we're going to use Pythagorean theorem to find the length of the side of a right triangle. Great job.